While learning about if statement, did you ask yourself, what if I also want MATLAB to do a series of commands if the condition is not true? MATLAB has an answer for your question. You can extend if statement functionality by using if-else statement. It is easy to understand how this statement works. So, according to the general form that I have provided here, if the condition is true, the action 1 is performed. Otherwise, action 2 is performed. I have also provided a small example which is self-explanatory by itself. Let's look at a more complicated example. Here I have written a script that calculates the area of a circle. In particular, it asks the user to enter a value for the radius. If this value is negative, the program complains with a message. Otherwise, the entered value is used to calculate the area of a circle with that radius. Here I have saved this script with the name checkradius.n. So that's how I call the script in MATLAB. But even the simple if-else statement can be extended by using nested if-else statements. What we mean by nested? We mean an if-else statement that is inside another if-else statement. So, how are the nested ifs useful? Let's say I have been given a continuous function that has various shapes depending on the input x. If x is less than -1, then the function simply returns 1. If x lies between -1 and +2, then the function returns x squared. Finally, if x is larger than 2, then the function returns 4. Let's see how we can implement this function in MATLAB. So, this is another concept. I want you to write a function. What is a function in MATLAB? Well, we have seen that already many times. All those sum, mean, plots, and similar commands are functions. They take one or more inputs and they perform some operations on these inputs, and they return an output. This output can be a scalar, or it can be a vector, or can be a matrix. Similarly, if we want to write our function in MATLAB, we have to first decide on the inputs that our function will get. Of course, our function must also have a name, so that's another important thing. Finally, we have to decide on the outputs of our function. While we know all this, we can start implementing a function. In this slide, I have unofficially shown you how to define a function. You can see the general form, which starts with the keyword function. Then you set the name for your function, followed by inputs. Then you provide the commands that you want your function does on these inputs. Finally, you should set the outputs of a function. The important thing about a function is that it must be served in an M file, and the file must be saved using the same name of the function. So, each function has its own M file. It's enough for now. We will specifically work with functions later. Alright, let's go back to our example where we wanted to implement our function f, which we introduced a couple of slides ago. So, what is the input of our function? It is x. So, start by creating an M file similar to what we did earlier. So I can press Ctrl and N keys, or I can click on New Function in Home tab. Then I start by typing function y equals calc parenthesis x. This way, I have told my MATLAB about the output variable of my function, which is y, about the name of my function, which is calc, and about the input variables, which is only x. Now, what does this function do? It is very easy to understand. Basically, it uses 3 independent if statements to verify the value of x and computes the value of y accordingly. So, I let you look at the details and, of course, use the commands that I have provided in the body of the function to see how this function works.